Hello, welcome to another episode of Getting Started with P5.js. Today we're talking about nested for loops. In the previous episode, we learned about how to write a for loop. Now, what if we nest them? What if we add a for loop within a for loop? That's when we can create a 2D grid. I talk about this in a little more detail in another episode, but we are going to talk about this specifically in relation to this series. And let's start by defining a few parameters, a few variables. And first, if we want to create a 2D grid, we want to know how many columns do we want to have. I'll start with a number like 10. And then how many rows do we want? Again, I'll start with a number like 10. And then based on these numbers, we can calculate the width and height of the column. So column width, or maybe I can call it tile width. So for each tile, that is going to be the entire width of the canvas divided by the number of columns. And then let tile height is height divided by row's height. And let me actually pull out the whiteboard just to illustrate what I mean by these variables. So I'm talking about having a grid like so. I'll have like relatively small amount of tiles. So this is what I mean by a single tile. So this number of columns, right now we have 3, 0, 1, 2, 0, 1, 2, starting from 0. We have 3 columns. And then the width of the column, or over here, this is tile width. That should be the entire width divided by the number of columns you have. The width divided by the number of columns that you have. Already have okay, number, yeah, really bad handwriting over there, but you get the idea. And let's get back to our code, and that's why we are calculating the tile height width and tile height based on those two numbers. And then, so we have some numbers. Of course, we haven't written any other code yet. Nothing's going to show up on the canvas. But this is where we can write a for loop. So let for, let column. So instead of I, we can use C. Let column start from 0, and the condition under which this keeps going is C is smaller than the column's number, and in between we could do C equals C plus 1. And there's actually a shorthand for the exact same thing, which is C plus plus. And let's use that one for loop for now, and we can then use the C to calculate the x. Then there's two ways to calculate the x. So one way we can do is to use this and times tile width. Okay, so that can be the x. And for the y, let's start with just 0 for now, and then let's create a width, and then we already have the tile width and height, so we can draw a rectangle. So x, y, tile width, and tile height. So we just created rectangles across the screen. Great. And then we can add another layer of the for loop. Let row equal to 0, row smaller than, just by following the same thing, and row plus plus. And make sure you put all these lines in between when you do a tidy code, so you can see the different layers of code with a different indentation. So y follows the same format, r times tile height. That's how you can get the y. So we have a grid over here. And this grid can also be circle, but once it's circle, because because we have both width and height, I'm going to use ellipse. That's why there was error, there was a warning. And when we have ellipse is based on the center instead of the top left. And again, let's get back to the whiteboard here. And because right now the way we are calculating it, x, this is a C, because c start from 0 and becomes 1 and 2 and 3 and 4 and so on and so forth, and then the row number 0 1 2 3 4 5 6, so on and so forth. And so now, so when we use 0 or the c times tile width, w, c times tile width, what we get is starting from 0, and this is tile width. I'll use tw. Yeah, tw, tile width, and this is essentially two tile widths. Maybe let me write the t properly. This is like 2 tile width, and then 3 tile width, and so on and so forth. So because, yeah, again, we are using this number times tile width, 1 times tile width, 2 times tile width, in order to get the top left corner of each rectangle. So now if you want to get the center, because we are drawing ellipse, you can either change the ellipse mode, which to adjust to use the top left corner to draw the ellipse, or we can calculate the center, which is more useful in some scenarios. That simply we add this by half of the tile width. To the x, we add half of the tile width, and then for the y, we add half of the tile height. And so let's get to that. So x, we can add half of the tile width, and to the y, add half of the tile height. And that's how we can get this. And then once we have this nested for loop, again, if we paste, I copied beforehand, so if we paste the face here, we can replace the ellipse with face. And that's how we can have so many smiley faces. And for the smiley faces, we can adjust the columns number, we can adjust the rows number to draw more faces. Can change this to 5. So that's how we can use a nested for loop to create a grid. And there's actually something pretty useful about having a nested for loop like this, is to create color, is to create like a gradient color. And let's briefly touch on that. There's another video that I explain that in a little more detail, but let's briefly touch on that a little bit. So we can, within the C and R, we can then use C and R to define a color. So what I'm going to do is what I'm going to do is to create a color, and that color, so R will have R value, G value, and B values, and for the red, green, and blue. So R value is going to be based on column, and because I know that columns goes from 0, so this is where we can either do a little bit of math, or we can use the math function to map this column number. So column equals to C, what's the minimum value for a column, which is 0. What's the maximum value for a column is column's number minus 1, because you can't get to column's number. Yeah, starting from 0 to 9, or in this case 4. And then what's the destination we want map to? We want to map to 0 to 255. So now if I first just give the other values a default value 0, and then we can use this color to fill R, G, and B. What did I do wrong? Oh, right. R value, G value, and B value. And then that's how we have color that's from darkest to the brightest. And then and let's talk about the for loop in a second. So for a for loop, for the map, yeah, let's talk about the map in a second. Going to erase these. Yeah. So for the map function, essentially what map function does is to map a number from one range, let's say in this case our column number. So and then we have the minimum column number 0, maximum column number maybe like 10 or a number, and then we can map that to another range. And that range, if it's 0 to 255, then it kind of map proportionally like so. So 5, in this case 5 will become a number that's roughly half of 255. But then there's sometimes you can do simple math to do the mapping yourself, but sometimes if this number is low, we can also map it from a number from 100 to 255. And then again, everything kind of proportionally change. Yeah, so with the map function, first you start with the variable and then or any number and map the number from the minimum value and then its maximum value, and then the destination, this is the source minimum and maximum, and then the destination minimum and maximum, 100 and 255. So let's try that. Back to here, and so for instance, if we don't want it to be 0, we can do like 100 to 255. So this would mean that the minimum for the red value is going to be 100, and then we can repeat the same thing. So map C0 columns number 2, 100 to 255. And then the same thing here, C0 columns number 1, 100 to 255. Oops, I forgot to close the parenthesis. So right now it's only shades of gray because the R value, G value, B value changes at the same time. So if we have some kind of offset, 50, maybe this is 150, that's where we kind of have different colors. And then this is when we can have color, or maybe instead of that, we are starting from the 255 and ending with 100, and that's where we can have different kind of gradient. And of course, the gradient will be more obvious if this number is bigger, maybe like 50. Let's do 50. The gradient is more obvious, but the faces are a little harder to recognize. So that's how you can have gradient. And then maybe the instead of based on the column, we can also base this on rows. And now now maybe I can do 0 to 255. Then we can have a gradient color across different across x-axis and y-axis, so it has all different colors. So this is one way we can use nested loops to create gradients. And thank you for watching, and I'll see you next time.